Now let's look at case number 4, wherein if we're gonna look here, two objects. So for example here, for the case number 1, we're gonna travel on the right direction, and for the case number 2 here, for the ball number 2, they are in the same direction. Then afterward, they stick together, perhaps because the first one is faster than the other one, and then after that they collided and they join together, rolling. And so let's look here. So this is the scenario for our problem number 1 for case number 4. Object 1 with a mass of 2 kilograms has an initial velocity of positive 2 meters per second, collided with object 2 with a mass of 1 kilograms traveling in the same direction at 0.50 meters per second. So they stick together and join in the same direction. So this is the illustration. So we have to calculate their final velocity after the collision and the kinetic energy lost. So let's have here our first given. So let's write here first our given. Our given here is that the mass 1 is 2 kilograms, and then the velocity 1, that would be positive 2 meters per second. That would be the initial condition. And then for the mass 2, that would be 1.5 kilograms, wherein the velocity 2 initial condition, that is still positive 0.5 meters per second. Now take note that here, for the concept for case number 1, it is positive 2 meters per second going to the right, and then also positive 0.5 meters per second. So ball number 1 is faster than ball number 2. And so after that, they will gonna collide. And so the next question here is that, what is the required? The required would be, what's the required here? Required is their final velocity when they join together. And so what is our first useful equation that we're gonna have? And of course, we have the momentum equation, or conservation of momentum equation, plus m2v2 is equals to m1 v1 plus m2v2. Now of course, we could have an optional condition wherein we could write the initial here, and then final. Now take note, I'm writing for the mass which is final, but this one is also important. For example, this one is explosion, so the mass would be totally different. And so we could have right here an option of final even though if it is constant. And so we can now plug in everything here. So we could have 2 kilograms multiplied to the initial velocity, which is positive 2 meters per second, plus the mass 2, which is 1.5 kilograms, multiplied to the velocity 2, which is positive 0.5 meters per second. And we could also have for the mass 1, what is the mass 1 here again? We have 2 kilograms, but we don't know the final velocity, plus the m2 here, we have the 5 kilograms, and then we can have the final velocity. And so simplifying everything, this one will be 4 plus 1.5 times 0.5. I think that would be 1.5 plus, that would be 0.75. Okay. And then this one is 2VF plus 5VF. And again, we could factor out the VF here. And then we could have 2 plus 5. And so this one we're gonna have 7VF. And so this one would be 4.75. And divide both sides, so that would be, sorry, I think this one is 1.5. Sorry. Okay. So be very careful also. And so this one, instead of 7, that would be 3.5 VF. And so VF would be 4.75 divided by 3.5. If you're gonna press our calculator, that would be 1.36 meters per second. And so notice that this one is positive, and when they join together, they are in the right direction. And so let's now calculate what is the energy lost. And so continuing with the energy lost, let me just have very important data. Just copy that, this case. And then we also need to copy this given. So let's just copy this given. Okay. And so this time, our required now is the kinetic energy lost. Okay, so we all know that for that equation, what is our equation? What is our equation here? That would be 1/2 m1 v1 squared. Don't forget that that is squared. Plus 1/2 m2 v2 squared equals to 1/2 m1 v1 squared plus 1/2 m2 v2 squared plus kinetic energy loss. Of course, we're going to have an optional that this one is an initial condition, final condition, and final condition. And so if we're going to write here everything, so we're going to plug in everything. So we have here the 1/2 multiplied to 2 kilograms multiplied to 2 meters per second square plus 1/2 multiplied to 1.5 times 0.5 meters per second square equals to 1/2 multiplied to 2 kilograms. I'm going to just write here the units. The velocity now here is 1.36, right? So that would be 1.36 square plus 1/2 times 1.5 kilograms times 1.36 meter per second square. Okay, and of course we're gonna have an energy loss for that. So we're gonna have plus kinetic energy loss. And so computing here, this one will become, let's simplify everything, 4 plus, I think this one is 0.183. Of course the unit here will be joules. And then this one is 1.850. And then next would be, this one is 1.387. The unit here is joules plus kinetic energy loss. Solving for this, 4 plus 0.183, that would be 4.183 joules. And then this one is 3.237 joules plus kinetic energy loss. So 4.183 joules minus 3.237 joules is equals to kinetic energy loss, and therefore kinetic energy loss That would be around 0.95 joules. Okay, so what could this be? 0.95 joules. It could be a heat energy, a sound energy, okay, or it could be on the movement of the internal energy of the molecules.